All right, continuing on from the previous video, what we are going to do is look at a little bit of how we can start to do error handling within Rust. There are several points here where things might go wrong, and we should probably return reasonable error messages when stuff does go wrong. So that way any users of our library or our module here that we're writing uh, can have better information about what happened. It's just a way of being friendly. Um, the way that we're going to do that is, number one, we want to return what's called a result type. So we're going to take what we would want to return and wrap it as a result. And the result type has a right and a left side. Or I guess the way we're looking at it, yeah, it's backwards. But this side, this is what we return if everything is okay, which in our case is this URI data. In the circumstance where something doesn't go right, I think what we want to return is our HTTP parse error. This doesn't exist yet. We're going to go create it here. When I do this, it's going to yell at us. And that's okay. I can take it. What we are going to do is let's go create a new enum called HTTP parse error. And for right now, we're going to leave it blank. And we're going to go ahead and add these derived functions onto it so that we can do different equality checking and the printing out of these values. Yeah, let's go ahead and go do a couple things. Number one, here it's unhappy because the output is not matching the type that we said it was. So we're going to erase that. And you can see that it's already doing type inference and seeing that this is actually coming back as a result. For the sake of what we're doing here, I'm going to go ahead and, for the sake of this call, I'm going to go and say, we assume every time you see this unwrap, what you're really saying is, we assume that the result is okay. Either we trust it or we've checked it. We'll get into more of that later. When you're trying to fast and just prototype things, you'll see lots of unwrap. You generally should not have a lot of unwraps in your code. Although let's quickly show what you can do if like the quickest, dirtiest way of handling that. So we get this back. It's actually this result type. What we can do is if URI data dot is error or is okay. So we're going to say is okay. And we're going to do this. Else. Basically, this is a binary either or. If it's not okay, then something's wrong. And that's a problem. So we're gonna panic right here. Blow up. All right, excellent. And we're just gonna copy and paste this into here. We're gonna shadow our URI data with URI data unwrap. And in this circumstance, this is okay. Like we have validated that this isn't like we are getting what we expect out of this. We know that this is going to be valid. And so, yeah, here we can go ahead and do an unwrap, and that's fine. We've handled it. All right, excellent. So anyway, let's jump back and let's start handling these other areas of our code. So when we're right here, this is a happy path, and that means what we're returning is okay. So we wrap it in an okay. Stylistically, this is just me. I like to indent my things like this so that we can have a little bit of visual distinction saying, okay, like this is the okay thing that we're returning. Here's the content of the okay. May or may not make sense, but it's the model that I built up in my mind here. All right, now let's do it. All right, so right here. We should probably not panic. A panic is basically going to kill the application. we should give it a chance to continue forward. And this is a good area where we can say, we're going to return a parsing error. And if we land in this use case, what's happening is that there are too many parts, or a wrong number of parts. So let's say wrong number of parts. I mean, maybe we'll change that up later, but maybe not. And it complains that this doesn't exist, which is true, but I'm going to tell it to go ahead and go generate it for us. And also, now this new error that it's complaining about is that the value that we're returning out of here doesn't match these other cases. So this is one of the, in my mind, one of the better advantages of Rust. That when you are, say, matching and then returning the results of that to a variable, all the different pieces must match up. They must be of the same type. We don't actually want to return this and assign it to this variable. We want to sort of return an error from this function itself. So to do that, we're going to say return and wrap this with error. And this way, we're making everything happy. So we get to here, we'll get this wrong number of parts error. The other place where we are running into an issue is right here, this inner string. So we are taking it currently as an act of faith that what we are passing into this method here, as we are creating a string, is an actual legitimate vector of bytes which are UTF-8 compatible. That's not always the case. This could fail, and at that case, this application will blow up. We want to be somewhat responsible about this. So what we're going to go ahead and do is use what initially may look like some weird syntax if you haven't done it before. But we're going to create basically a lambda in line with our code by creating a block. It's just, an anonymous function in here. We're not going to unwrap it, but what we are going to do is we are going to say, let's say, if let okay. And as a matter of fact, let's back up. So I'm going to hover over this, and we can see that this function signature, it's going to return a result of string or this UTF-8 error. I mean, we could, if we want to, propagate this upward, but this by itself, it's not necessarily helpful. So if somebody else is using our library, and we'd return this from UTF-8 error from wherever, I know for me, if I'm using this and I got this random thing buried deep within some other library, I'd be a little bit annoyed because it's not actually helping me. So what we're going to do, instead of returning this from UTF-8 error, is we're going to return our own custom error. So yeah, we're gonna say let, and this is where it's going to look a little bit funny. String data equal to this. And we're going to say if let, okay, string else. We're going to handle that okay in just a little bit, but what we want to handle here is returning an error. Return an error of our HTTP parse error. And we're going to create a new type saying invalid invalid bytes in, or let's call it this, let's do this, non-UTF-8 bytes in header, HTTP header, because we'll run into other types of headers. All right, cool. Let's go ahead, let it generate that variant for us. And then here, we are just going to return out of this little section of code this anonymous function that we've created, we're going to return this and have it be assigned to this. So that's great. This means we don't have to go define some other function, and we can have an early escape if something goes wrong. And we have a slightly more descriptive error message that users of this particular module will see that tells them, hey, we tried parsing the header for UTF-8 bytes. We found something that wasn't right. And again, it's in the HTTP header. In my mind, that feels better than just giving them a parsing error. Like, not UTF-8, bleh. So I like this. I feel like this is a better way to approach this. As a matter of fact, since we copied this code from somewhere else, let's go and correct it elsewhere. Let's go. Inner string. Here we are. We are going to not do that, but we are going to do this and that. Yep. And that means also here that we are going to do result and HTTP parse error. Oh, you're trying to help me. I get you. I appreciate that. We're going to rearrange this and paste that here. Okay. So we have our error, and let's go back to our happy types. And we're going to say, maybe it feels a little bit funny, but we're going to say this is actually okay. This is expected behavior. Let's go ahead and slap an OK on all of these here. And let's do multi-line. There we go. And let's go do OK. And cool. And also an OK here. All right, excellent. So I think this is good. Where else are we getting? We're getting yelled at here. All right, I'm going to email in words here, and for expediency, we're just going to unwrap it. All right, moving on. Yeah, so here is an example of using the result type. It's more of a type wrapper, I would call it, or a parent type. I don't know. You can wrap result around anything inside of Rust. There's another type called option. So anywhere in other languages where you might have null or none, you're going to use option instead of Rust. So if you have a generative function or a function that goes and reads bytes from a file or whatever, if you are unable to generate something and it's not necessarily a destructive or an erroneous result, instead of returning null, you're going to return an optional type, and the caller of your function can tell, is there something there or is nothing there? And it just makes things nice. You don't have any dangling bits of data there, which is nice. All right, cool. I think that's enough. And starting in the next video, we're gonna do more parsing of data. Specifically, we're gonna be parsing these other keys inside of our header. So, looking forward to it. See you next time.